Good everyone. In this tutorial video I'm going to go over the content, well the majority of the content that was covered in the, I don't know what week it is, but the Prac 9 material, which is when we're looking at hypothesis testing on means. I believe proportions were also covered as well, but in this video I'm just going to be looking at testing on means as opposed to proportions. However, everything that what I do within here can be translated. So essentially everything that's been set up here, the only thing that changes is instead of having population mean is equal to some value, would be population percentage equals some value. So essentially everything remains the same. There is a couple of differences that do exist within it, and I'll definitely go through those in detail. Okay, so again here we're going to be looking at testing on the mean. So I've just opened up the data from Prac 9, which is go data set, and we have one continuous variable here that we're looking to ask questions about. So if we have a look at the time in seconds, we may be able, well, we can definitely form the average. So let's find the sample average, and let's just go here. I'm just going to get rid of everything. I'll keep the standard deviation and everything out, and let's just have a look. So we can derive the sample standard deviation, absolutely no problem whatsoever. So we find that the mean here is equal to 3.8066, and we've got a standard deviation of 0.78. If we were to generate, say, a histogram of that, let's just see how normally or abnormally distributed it is. So this, we've got a fairly normal distribution that we've got a fairly normal-like distribution that we've got here. We can see here it sort of follows the general trend. It's definitely skewed a little bit, but overall it does appear to be normal. The question then becomes, this mean that we have here as part of our sample, does that reflect the population mean? Or, alternatively, if you don't have that situation in play, you may have collected certain data, but you know that there is a true average or a hypothetical population average that should exist. So let's just say, for instance, there was some study that was done. I'm not sure exactly what this data is actually covering in this case, and they found that the population mean was found to be about 4.1. The question then becomes, based upon the data that we've got here, can we still assess that conjecture? So when we're dealing with a one sample situation, that's essentially what it means. It just means that we're dealing with one sample set of data. If, however, though, we wanted to compare means, so let's just say we wanted to compare the average between male and females, that's a classic example, then that would be what we refer to a two-sample test, because we're separating the total or even though it's a sample, but we're separating out the data into two samples. One set for being the males and one set for being the females, and then we can ask questions about how their averages compare against each other. So when we're dealing with the one sample case, just to start off with, we can ask three different types of questions, and the three different types of questions are all listed here. So it's either remember that at the end of the day we're really only interested in the alternative hypothesis. So the three different questions are, is the population mean not equal to some value? And we can set that some value. So in our case it might be that the population mean does not equal 3.8. We can test whether or not the population mean is less than some value that we assign, or it's greater than some value than we assign. And then when we extend it into the two sample, we'll go into this, and I'll go through those when we need to. So when we're dealing with a one sample test, the question becomes, when do we use a when do we use a Z distribution and when do we use a T distribution? Well, it's a very simple rule. When the population variance is known, you use the Z distribution. Otherwise, we use a T distribution. Okay, so let's go by the situation that we actually know what the population variance is equal to. And I'm just going to make a guess here. It's saying it's 0.78. Let's just say we know for certain that the population variance is equal to 0.8. And wait a sec, I have to be careful here. So it's not 0.78, we want the population variance. So what I'm going to do is I'll just get it to calculate the variance as well. Where is that? I thought, here we go. Okay, so it's just a square, you can do it with the calculator. But let's just say it's 0.6096. Let's just say that we know for whatever reason that the population variance is equal to 0.6. So as we know the population variance, we're going to be using a Z test. And so then in terms of how we proceed forward, we just need to follow these 4 steps. So So we see here we need to form our hypothesis, then we generate our test results using Minitab, interpret a p-value, and then form the conclusion based upon that. Now, forming the hypothesis depends upon what sort of question that we want to ask. So if we want to test whether or not it's equal or not equal to some value, then we'd use this test. If we want to test whether or not it's greater or less than some value, then we would use one of these tests. So as before, when we had a look before, the mean is equal to 3.8066. So let's just test to see whether or not the actual population mean is close to this. So let's just round it off and let's test to see whether or not the population mean is 4. Okay, so in this case, the way that we would define it is it would be H0, in this case, population mean, and you would have to define which mean that you're referring to in this case. So when we say population mean, we mean the population mean average time in seconds for this situation. I haven't defined it here, but that's what we're dealing with. So the population mean is equal to 0.4, and then we want to test the conjecture, is the population mean not equal to that value? 0.4. So let's perform that test. So we've set up our hypothesis. We now need to generate the test results using Minitab. So let's do that. So in order to do that, we just go to Stat, Basic Stats. We're doing a 1 sample Z. We need to tell it where to get the data from. So we've only got 1 sample here. You can have it in multiple situations, multiple different data layouts, I should say. But if you've just got the case where it's all just listed in one column, then you just follow this situation. This example, I mean to say. So we click time in seconds. See how it says it's got the known standard deviation. We need to put this in, and my memory's terrible, so I have to go back. So we've got the population variance is equal to 0.6. So in that case, that would mean that the standard deviation would be roughly 0.78. So I should probably find exactly what it is. Accessories calculator. So we want to do the square root of 0.6. Let's do the square root of that. So I'm just going to round this off to 0.774. So the known standard deviation for the population is 0.774. Now we want to perform a hypothesis test, and in this case the hypothesized mean, going back to our situation, is 0.4. Oh, wait a sec, have I done that correctly? No, I meant to have, I meant to have 4 for the mean. I'm not sure what I was doing there. So the population mean is equal to 4. Population mean is not equal to 4. My apologies for anyone who's confused. So the hypothesized mean is equal to 4. But now we need to tell it which type of test are we going to do. So in this case, we've just got an equal, not equal situation. So we need to click the options and see we've got the mean does not equal the hypothesized mean. If I wanted to test it was less than that value or greater than that value, I would choose one of these 2 options. Leave the confidence interval at 95%. That's just a stock standard that we use within this class. We don't really need to include any of these. You can if you want to, but there's no need for the actual assignment. So we click OK, and we get our output. So what I'm going to do is I'm just going to copy this over. The reason why I'm not doing the send selected lines to Microsoft Word is I'm not sure exactly how it'll copy and paste in this case into here. Hopefully it won't be too bad. Yeah, it seems to be. Wait a sec, it didn't like that, so maybe if I go... I hate using Word. Anyway, you get the gist. This is meant to be number 2 here. Yeah, whatever. Okay, cool. So really the only thing that we're interested in this case is interpreting the p-value. So in terms of interpreting the p-value, it's exactly the same as for every other video I've done and for everything that we've been taught within the class. So we just list it in a very simple fashion as the p-value, which equals, in this case, 0.009. So we've got roughly 0.9%. In this case, we have very strong evidence to reject the null hypothesis. And so basically, yeah, so we're interpreting the p-value in terms of how we're going to interpret the null if we're going to accept or reject the null hypothesis. So we have very strong evidence to reject the null hypothesis and accept the alternative hypothesis. And then in terms of forming the conclusion, it's just something, really short and sweet. As a consequence, the mean time, I can't even remember what this actual mean time is for, but the mean time of, and you would insert that in, I think it's got something to do with car times, is not 4 seconds. So that's what we were able to do from this. If, however, we'd done the situation in which we changed this to say being, let's make that greater than 4. Let's have a look to see what the results would be. So I'm not going to write out it, but this is how write out in detail all the hypothesis and everything. So if we go to one sample Z, everything stays the same. The only thing that changes is this is going to be that it's greater than that. Click OK, and see we've got a p-value of 0.995. So in that situation, we have very, very, very strong evidence. It can be, what I meant to say is we have very, very, very poor evidence, or virtually no evidence, to support the alternative hypothesis. So remember, the alternative hypothesis was that it was greater than 0.4, and so therefore we know from this hypothesis test that it's definitely not greater than 4. But it may be less than 4. That is the other alternative. We've tested not equal to 4, greater than 4. The last test would be that it's less than 4, I apologize. So where are we? Basic stats, one sample. Again, everything remains the same. We're just going to change this to being less than. Click OK and see if we get a result here. So in this situation, we get a very small p-value. So we find that in that case, we would be accepting the alternative being that it's less than. So essentially, that in that case, we would then be able to conclude that the population mean for the time in seconds for these cars is actually less than 4. So depending upon what test, you may want to run multiple tests on the situation. There are the different results that we can get. Okay, so now let's look at a situation where we have two sample Z-tests. So what if I wanted to compare the population averages between males and females and to see if they're either equal, if one is greater than the other, if one is less than the other. So males might drive on average at a faster rate than females. They may drive at a slower rate than females, or they may actually be on par with females. We can investigate that using a 2 sample. So again, it's 2 sample because the continuous data is split into 2 different samples, the males and the females in this case. So let's just go by a bit of a stereotype here, and let's say that males go faster than females. So let's say we want to test that out. So again, the first thing we do is we form our hypothesis. So remember, these are the 3 different forms that it can take. So it always, when you go into Minitab, it always puts it in form of the difference. So when we look at it in this case, we're always comparing against some value, and the same thing is true, except for the sum value is always 0. So if the population mean minus the population mean 1 minus the population mean 2, if that doesn't equal 0, then that means this is another way. If you rearrange this equation, that's the same as saying population mean 1 does not equal population mean 2. If we say that the difference is greater than 0, then that means mean 1 is greater than mean 2. If we're saying that the difference is less than 0, then that means mean 1 is less than mean 2. You can either write it out in this form or this form. They're equivalent. Okay, so as I said before, we're going to go by the stereotype here, and we're going to test to see whether or not males are actually faster. So population mean for males is greater than the population mean for females. Okay. And the population, so in this case, the population mean for males is equal to the population mean for females as our default null hypothesis. Okay, so now we need to generate our results using Minitab, so let's do that. Okay, so we go to time in seconds. Oh, we don't go to that. We go to basic stats. We're going into a 2 sample. Where is it again? I think we go into this. We go into the summarized data. Actually, let me just pause this for a second. I'm not sure where it is. It's a little bit different to Minitab 16. So I'll pause it and come back. Okay, I just had a look through, and it doesn't seem that Minitab 17 supports 2 sample Z-tests. So go figure. 2 sample Z-tests are very, very rare anyway, because just like a 1 sample Z-test, you need to know the population variance. And so when you're performing a 2 sample Z-test, you need to know population variances as well, and that becomes very difficult. So what I'm going to do is I'm going to leave this. I'm more than happy to go through an example of all of this, and I'll try and find, I did find a macro online that you can actually install into Minitab 17 and 16 and will actually perform the test, but realistically you probably won't be ever dealing with a situation where you know both of the population variances. So let's jump into the situation here when the population variance is unknown. And so everything stays exactly the same in terms of the method I don't know, how do I restart it? Here we go. The only difference is that you're using a different type of test. So in terms of forming the hypothesis, it's exactly the same. So in the previous one sample, we looked at the population mean being greater than 4. Let's have a look at a case where, let's just take this, and let's look at it for when it's less than. So we're going to form our hypothesis, population mean, in this case is going to be less than 4. So that was meant to go there. I'm really sorry, I hate Word and I'm not really good at using it. So let's get the Minitab output. So we just go to stat, basic stats. We're doing a one sample T. So we've got one or more samples each in a column, time in seconds. Excuse me. And in this case, we want to perform a hypothesis test. And the hypothesized mean in this case, let's just go with exactly what we had before. So the hypothesized mean is equal to 4. And we want to test a situation where the mean is less than the hypothesized mean at the 95% confidence interval. Level of confidence, not confidence interval, sorry. So we click OK, and we get our results here. So let's just copy this across. We'll just put, again, my apologies if this doesn't come out very nice. Seems to do the job here. Okay, so the thing that we now need to do is we need to interpret the p-value. So just like with anything else, it becomes a very simple task. As the p-value equals 0.007, we have very strong evidence to reject the null hypothesis and accept the alternative hypothesis. We then form our conclusion, and it's basically just a worded version of this. Therefore, the population mean time, again to remember, I don't know what it is less than 4 seconds. And that's it. So when we go into the 2 sample t-test, I might just bring this onto a new page. In terms of how we set it up, it's exactly the same in terms of what we have for the 2 sample z-test. So I'm actually just going to copy this. We'll test this conjecture out. So what I'm going to do is I think I can restart a one there. Okay. So let's just put our hypothesis in there. Okay. Alright, the next step is that we need to identify if the population variances are assumed equal or not. So when it comes to 2 sample t-tests, well, the reason why we know we're doing a t-test is because we don't know what the population variances are. But there are 2 different cases. We can either assume them to be equal, or we can assume them not to be equal. Depending upon your situation, you can make that assessment. If you have absolutely no idea, then I would obviously err on the side of caution and assume that they're not equal. If you are in a case where you can assume that they're equal, then by all means you can do that. Basically, like when you're doing these things by hand, it changes the process. But in terms of how you interpret the output when it comes to Minitab, it's all exactly the same. So here, let's just assume that they are not equal. So in that case, that means that we're going to be doing, it's either a paired, there's 2 different terms. I think it's when we assume they're equal, you call it a paired t-test, and then if they're not assumed to be equal, anyway, I can't remember. It doesn't really matter. It's just one of the options in Minitab. Very easy to do. So okay, again, we're measuring if males drive faster than females on average. So we go to stat, basic stats, 2 sample t. So in this case, we've got both, both samples are in the one column. The samples come from time in seconds, and here we're going to split it up based upon gender. In this case, we're going to click the options. You'll notice here the assumed equal variances. We're not going to assume that, so we'll leave that unchecked. However, if we were, obviously we would check that box. So we're not going to do that. And then in terms of the difference against the hypothesized difference, when it's talking about the difference for what we're dealing with, the difference is always 0. So when it comes to, you can deal with other situations in which the hypothesized difference is not equal to 0. So what I mean by that is if we then change this to 4 and change that to 4 and go through the whole way. So instead of comparing it directly mean 1 against mean 2, it would be, well, mean 1 in this case here. So what I mean is, let's just change this. What if we have these? Then the way that this would change is it would be population mean is equal to population mean plus 3, or population mean 1 is greater than population mean 2 plus 3. So it basically means is if we want to set a minimum difference between the two, we can. However, for what we've been taught in class, we've only ever dealt with the 0 case. But if you want to have, a minimum difference, then by all means you can do that as well. In our case, though, for what we're dealing with, the hypothesized difference is going to be equal to 0. And the type that we're looking at is where am I again? That the hypothesized difference is greater than 0. So the reason why I know that the hypothesized difference is greater than 0 is that, remember that this can be written as population mean males minus population mean females is greater than 0. So that's another way of writing this. So the hypothesized difference of 0, in this case, or the hypothesized difference is assumed to be greater than 0. So that's what we're doing in this case. So the difference is not equal to the hypothesized difference. We're looking at the difference. So the difference between the two. So remember, difference between males and females is greater than the hypothesized difference, and we're setting the hypothesized difference to be 0. Click OK. OK, it comes out with all of the values. Okay, so we copy all of this. So we're going to copy, jump into the document here. And I'm going to try and do this without destroying the stuff underneath. Oh, who cares? So anyway, so this is all the results that we've got. It actually gives you, and I should have actually mentioned this before, usually they give you the confidence interval in as well, but it doesn't seem to be in this case. That's alright. So now we just need to interpret the p-value, and we need to form our conclusion. So in this case, as we've got a p-value of, in this case, a very strong p-value, 0.608, we have very weak evidence to reject the null hypothesis. Okay, so as a conclusion, so why did this go to 11? Therefore, the mean time for males is not greater than the mean time for females. And that's it. That's all you need to know when it comes to hypothesis testing on the mean. When you're dealing with a one sample situation, you've either got the Z distribution, when you know the population variance. If you don't know the population variance, that's when we do a one sample t-test, which is covered here. And then in the situation, we're not going to consider this case of the two sample Z-test because it doesn't really ever happen in real life, or very rarely. So then when we're dealing with two samples, when we're comparing two different means against each other, we can attack it this way using the t-distribution. So anyway, I hope that was informative. I'm going to do up another video tomorrow showing you how to do all the confidence intervals for each of these. It's very simple to do. In fact, for most of the cases, I think it's just a matter of you go to stat, basic stat. Where is it again? I can't remember exactly off the top of my head, but I'll look this all up and I'll put it into a video that I'll release tomorrow. So anyway, I hope you like that. Let me know if you've got any questions and I'll get back to you as soon as I can. Okay, thanks. Bye.